Hello! Today we will be looking at the first part of the three-part tutorial series. In the first tutorial, we'll dial in the simulation. In the second one, we'll tackle look development. And finally, in the third part, we'll do some light compositing. I hope you find these tutorials useful and pick up something new along the way. Let's create a geo container, call it setup. I like to color mine red, so let's do that and jump right into it. We would need a box, just a simple box, but we will squish z-axis to 0.01. Nothing fancy so far, but we will fix that later. After the box, let's create points from volume. And I would like to lower particle separation to 0.01. Maybe even something lower, like 0.005. So we would have around 80,000 particles. Next, let's create a group. Set it to points, call it density, and it should be bound in box. I would like to shift mine to center, so 0.5 in center y-axis. And let's set it up a bit, in case we will change our box size later. Next, we would need to create density and viscosity attributes. And there are several ways to do that. First one, let's create point swap, run it over density group. If we jump inside, we can create bind export node. In the name field, type in density. Let's copy it and type in viscosity. If we middle mouse click and promote parameter, we will be able to reach those parameters outside of WAPNet. But I forgot to label mine, so let's do this real quick. Let's copy density and paste it into label. And let's do the same for viscosity. So now that we have them nicely labeled, we can control density and viscosity through point swap. But there is an easier way to do that through attribute wrangle, so let's create one. Run over density group, and let's write a simple script. So f at density equals channel float density. And let's do the same for viscosity. So f at viscosity equals channel float viscosity. You could also use attribute create node, but I prefer wrangle. Let's click icon in the right corner and set density to 10. So we have the same setup as we did with point swap. You could use either one. They basically do the same thing. Next, let's create null, call it flip, and connect wrangle to it. That's going to be our source. After that, we would need dot network. So let's create one and jump right into it. For that, I have my second network view. And by the way, to quickly jump between contexts, you can hold N and choose whichever context you want. So let's dive right into the .NET. In here, we would need flip object and flip solver. Let's quickly create them and wire them to an output. As you can see, it looks nothing like our source points, but that's fixable. All we need to do is go into flip object and change input back to particle field and drop our null into subpath. Next, what I would like to do is change our preview type from spheres to actually particles. So let's do that real quick. Another problem we have is our collision box doesn't match with the box we created earlier. But that's an easy fix as well. All we need to do is go into the flip solver and copy the size from the box we had earlier. If we use relative reference, they will stay always connected to one another. We can do the same for the box center. Now our collision will match to the box we have in our sublevel. Let's visualize our density attribute. Control middle mouse click on the null and toggle density. Now we can see density attribute visualized. So 0 and 10 in our case. We still have a few things to do in the DOP network. First, let's create gravity node and wire it up. In flip object, what we have to do is change particle separation to the one we had in the points from volume. So copy relative reference and paste it in there. As you can see, now they are the same. What we need to do next is click closed boundaries, so our simulation doesn't go beyond those. I would say that now is a good time to do our first simulation and see what will come out of it. So let's save a scene and click play. There is definitely something wrong with the simulation, so let's stop it. And first, I would like to change velocity type to swirly, and I forgot to enable density and viscosity attributes. So let's do that real quick. And while we are here, let's see what else I might be forgetting. We could enable reseeding, but that's not necessary for this simulation. What I would like to do is enable ID attribute because that will come in handy later. Everything else looks good so far, so let's save a scene and click play. We definitely see nice swirls in there, but they're too fast for my liking. We have a couple of ways for fixing that. What I would like to do is go into the dot network and change time scale to 0.2, let's say. Now they are nice and slow. That's what I was looking for. We do have nice swirls, but we can make them even better. First, let's scale up the box so we would not be able to see the edges of our simulation later. And run it again. Yeah, that's still good. It would be nice to have noise, not just flat density, so let's dive into point swap and create anti-alias noise. We can visualize this noise if we plug it into the color and disable our density preview. This noise goes from minus 0.3 to 0.3, so let's wire up the fit and type in those numbers. We would also need a ramp, so let's quickly do that. I would like to color my ramp noise and change the type to spline ramp. We could plug it directly into the density. Right-click on the noise, create input parameters. Now we have control over our noise outside of point swap. Let's enable density visualization again. As you can see, it's all black, but that's because ramp is at 0. Let's quickly dial in the frequency of the noise. Something like that should work fine. I would like to lower roughness as well. Now we can wire up the point swap instead of wrangle into the flip null and run the simulation again. Nothing is happening. That's because our density is at 1 and it was at 10. Let's maybe crack it up to 15. Now we almost can see the noise in the density. But to better see it, let's go into visualization and change the maximum to 15. Now we can see much more details in there. Let's let it run and see how many usable frames we can get out of it. There are definitely nice patterns in there, but at some point it just becomes too noisy. So I think around frame 200, that's going to be the end of our simulation. Let's add retime and change the mode to by frame. We would have to do some little tweaks here. That should be good. Now we can get to animation. So let's go to the first frame and set keyframe to 1 and go to the last frame and set keyframe to 200. We could also increase cache memory size, so more of our simulation is fitted into the RAM. Let's wait a bit and see how our last frame looks like. Honestly, not so bad. I think I could decrease point size in the viewport, so it would be easier to see details in there. Obviously, our first frame is frame 1, and I would like to change that. Maybe something around 120 would look closer to what I want. Let's see how the speed looks. Not bad, but we can see some jitter in there. Luckily, that's easy fixable. We just need to change interpolation to subdivision. Now that looks smoother. I would like to play with start and end frame a bit, maybe come up with some nicer values. I think starting at frame 100 looks good. Maybe we will change the last frame as well. Let's try something like 250. That's a bit too much, 220. I think 200 was good. Now we're close to caching our simulation, but first let's see what attributes we have. And I see that we don't need all of them. So let's add attribute delete. Click delete non-selected and select density and ID. Now that looks much cleaner and we will save space on the drive. Let's add file cache and we will be caching to the cache folder. Let's call our simulation flip scene 01. Maybe flip scene 02 because I already have 01 in that folder. The rest of the fields looks good. And I think that we are ready to save to the disk. Now that it's done, we can see how it looks like. Nice details in there. But I think we might have a little bit too many particles. But anyway, let's see if that's going to be a problem later. Let's add attribute randomize and randomize color. To see color, we need to disable density visualization. Important thing is to use ID attribute as a seed. Right. After that, let's add another attribute randomize and randomize p-scale. That's a float attribute. We use ID as a seed again and use custom ramp. The minimum is set to 0.01 and maximum is set to the same for now. And let's preview disks so we would be able to assess their size. Now we could adjust minimum and maximum values more comfortably. That looks good for now, but we will come back to that later. It's always a good idea to start rendering as soon as possible, but first we would need to make some little tweaks. Let's add transform and lay our simulation flat. And also bring back density visualization. Now let's make some more room. And I would like to add some noise. So let's drop mountains up. As you can see, nothing happens. Not because we need to click off noise along vector. Now that's closer to what I want. Let's maybe drop down roughness. And play with the amplitude and element size. Right now, noise goes into all directions. I would like it to go only into y-axis. And just a little bit more tweaks, and I think we will be good to go. Let's set amplitude to 0.2 and element size to 0.2 as well. Maybe element size a bit bigger and amplitude a bit smaller. That looks closer to what I want. Now I would like to displace our density attribute, so let's drop 0.1. But actually, before we do that, we should add attribute remap and remap our density attribute to itself. We should set input max to 15, because if you remember, density goes from 0 to 15. So if we do that, our new density goes from 0 to 1, and we can adjust our visualization accordingly. Now it would be much easier to work with. So let's jump into point swap and add the bind node. Into the name field, let's type in density. I would want to split position into its components. So let's add vector to float and float to vector. If we connect x to x, y to y, and z to z, and wire all of that to the position, nothing changes. That's because we don't do anything. Let's add node. But before we can wire in density into that node, I would like to get a ramp. That ramp should be scalar, and let's call it ramp density. The same goes in the label. Now we can wire up that ramp into the add node. As you can see, effect is quite drastic. We should lower our ramp to a really small value. Something like 0.01 should be good. Let's maybe clamp it on the 0 as well. Something like that looks good to me. And finally, let's add null and call it out points. Now we are ready to start rendering. Let's copy our null, create geo container, call it points, render, and drop inside. In here, we would need object merge and paste our null into the object field. Let's organize our network just a bit. I like to color my render nodes into green. To render particles in Redshift, we should take render objects as particles. And now let's split screen so we can add Redshift render view. We don't have any camera to render, so let's create one, call it cam01, and let's look through it. I would like to set resolution to 180 to 1920. And let's maybe try and find some nice angle for our camera to look through. I would like to change focal length to something like 150. That should be good. Let's also increase point size for our particles, so it would be easier to see them. And let's maybe jump to frame 150, so we are right in the middle of our simulation. And finally, to start rendering, we would need lights. So let's add dome light. We could leave it white for now, but I have an HDRI pack that I really like to start any look development with. So let's maybe load up one of those HDRIs. Number 13 is my favorite. We don't have rope network node, so let's create one. Let's call it cam1 and check that the camera matches. It does. Now we can start rendering. It doesn't look like much for now, but it never does at the start. So I will see you in the second part, where we will start working on the look development in Houdini and Redshift.